Hey guys, this is Mr. Teen Tutor, and I'm going to continue my discussion about the unit circle and the trigonometric functions. So if we come to this board right here, which I drew for you guys in the last video, it outlines the common slash major trig angles along with their coordinates, and we're going to use that to find the individual trig ratios for any angle. So we're going to start with 5 pi over 4. So when you approach these kinds of problems, you got to say to yourself, what are the coordinates of 5 pi over 4? I would hope that you guys have memorized this, but if you didn't, that's okay. Just picture this unit circle in your mind. Not physically, of course. That would be cheating. And we see that the coordinates are, I know it's tough to read, is negative root 2 over 2, comma, negative root 2 over 2. By knowing these coordinates, life will be a lot easier. Because as I mentioned in the last video, in order to find the sine of an angle, you simply take its y-coordinate, and to find the cosine of an angle, you take its x-coordinate. So we begin with sine. What's the y-coordinate? Negative root 2 over 2. And then same thing for cosine. And tangent is sine of the angle over cosine of the angle, or in other words, in terms of the coordinates here, y over x. This divided by this. What is that? You guessed it, 1. And here's another thing about what this tangent of an angle means. If you think about it very carefully, the tangent of any of these angles right here, any of these angles right here, represents the slope. Think about it. 5 pi over 4 and pi over 4, the tan is 1, which means that I can connect a line that goes through those 2 points in which the slope is 1. So that's essentially what the tan of an angle stands for. It's the slope of the line going through that point, if you think about it. Now we come to cosecant, which is, again, as I said in my previous video, 1 over sine theta. So you simply flip these so that it's 2 over negative root 2. Now that's fine, however, teachers would want you to rationalize, meaning that let's first put the negative here and work with the radical down here. So we multiply this by radical 2, this by radical 2, so this is negative 2 root 2 over 2, which simplifies this to root 2. And since this is the same coordinate here, the secant of the angle is also negative root 2. And the cotangent is still 1, because 1 over tangent, 1 over 1 is still 1. So there are your 6 trigonometric functions right there. Remember, you have to rationalize the denominator unless your teacher tells you not to. That's important to do, because if you just write negative 2 over root 2, even though that is correct, teachers may take points away because it's not rationalized. So make sure you do that, and make sure you keep in mind that sine and cosecant are inverses of each other, cosine and secant are inverses of each other, and that tangent and cotangent are inverses of each other. We're going to do one more angle, and this is 7 pi over 6. So again, you want to think about what the coordinates are for this angle. You should have memorized it by now, of course, but once again, if you don't remember, picture the unit circle in your mind and look for 7 pi over 6, which is right here, and the coordinates are negative root 3 over 2, comma, negative 1/2. What's the sine of 7 pi over 6? It's the y-coordinate, negative 1/2. Cosine, negative root 3 over 2. Now tangent. This is where we got to do a little work. So it is equal to sine of the angle over cosine of the angle, or y over x. So right here we're going to show a little bit of work. So let's put the y-coordinate down, which is negative 1/2, divided by negative root 3 over 2. So this is equal to negative 1/2, remember, times, remember your rules about fractions, times 2 over negative root 3, so the 2's cancel, so I'm left with 1 over root 3. And again, rationalize, that's vital if you want to get this correct. So there you go, the tan is root 3 over 3. Cosecant, again, flip that, it's negative 2. Here, negative 2 over root 3, again, rationalize, even though negative 2 over root 3 is correct. So So it's negative 2 root 3 over 3. And then cotangent, it's 1 over this, meaning just it's 3 over root 3. And when we rationalize that, we obtain root 3, because it's 3 root 3 over 3, which simplifies this to root 3. So there you go. I have identified for this angle the 6 trig ratios. Once you know the coordinates for the unit circle of each of these angles, then it won't be that hard to come up with. Now, of course, if you're given an angle, and let's say it is not given on the unit circle, then you have to simply draw a picture of it, and then you have to find the lengths from there. You can't necessarily, you can use the unit circle for reference, but of course the angle may not be there. Now, of course, if they ask you, say for an example, find the sine of 5 pi over 12, you don't have to use your calculator. You can actually get an exact value of it, but it doesn't deal with just knowing the coordinates of it. It involves other concepts that actually involves sum and difference formulas, which is what I'll get to in a little bit in my next video. So I hope you guys understand now how using this unit circle right here can help solve equations like this, and if you remember how to do these kinds of things, you will do fine on this particular part. Thank you.